Hi Yen here. Welcome to our fascinating science channel. Dear friends, asteroids have always been precious treasures for the scientific community. They are primitive objects left over from the formation of the solar system about 4.6 billion years ago, and preserved in the vacuum of space, so they have high research value. Therefore, to understand the early period of the solar system, scientists should start with asteroids. Recently, preliminary analysis of samples collected from asteroid Ryugu showed it contains essential molecules for life. This is an important discovery that helps scientists soon answer questions about the origin of life. Previously, in September 2022, scientists also discovered water on this asteroid. It seems that asteroid Ryugu is bringing new hope for extraterrestrial life. So what is the truth behind this story? Please join us in today's video to find the answer. Wishing you relaxing and informative moments. Now, let's explore together. Ryugu is a carbonaceous asteroid about 1 kilometer in diameter, located between Earth and Mars. Of course, this asteroid also has an orbit around the Sun. The closest point in its orbit to Earth is about 95,400 kilometers away. Therefore, it is classified as an Apollo group asteroid, asteroids with potential risk to Earth. In terms of composition, this is a carbonaceous asteroid with many small rock blocks containing blue and red materials, similar to a rare primitive meteorite found on Earth. According to researchers, this is material from the early days of the solar nebula, a cloud of gas and dust believed to be the origin of the solar system's formation. Due to not being affected by cosmic radiation, the rocks in asteroid Ryugu remain in their original state. Since they were born in the solar system about 4.6 billion years ago. That's why it has great research value. If we obtain samples from asteroid Ryugu, it's no different from as holding the key to unlocking the secrets of Earth and the solar system's formation. In 2014, Japan launched the Hayabusa 2 spacecraft to explore and collect samples from Ryugu to bring back to Earth for research. By 2018, the spacecraft had reached Ryugu. It successfully performed 2 sampling operations in February and April 2019. Subsequently, the precious samples were successfully transported back to Earth on December 5, 2020. Currently, the latest analysis of samples from Ryugu shows that asteroid Ryugu contains many organic molecules. The term organic molecule describes a range of compounds containing carbon elements, combined with hydrogen, oxygen, nitrogen, sulfur, and other atoms. These are the building blocks of all life forms on Earth. Therefore, they are also called the building blocks of life. Researchers conducted experiments on a small portion of the sample. Results showed that asteroid Ryugu contains many important organic molecules for life, including 15 types of amino acids. These are substances that living organisms use to create necessary proteins, regulate chemical reactions, and form structures like hair and muscles. These molecules themselves are not alive, but because they are present in all life on Earth, scientists call them the fundamental building blocks of life. Additionally, these molecules can also be created by non-biological processes, such as chemical reactions that can occur in asteroids. So far, the findings about amino acids from Ryugu match what has been observed from other asteroids and meteorites. Previous studies of meteorites found on Earth indicate that space rocks can contain organic matter. However, because meteorites have passed through Earth's atmosphere and been exposed to Earth's polluted environment, it's impossible to determine the exact origin of these organic molecules with certainty. But the new research results from Ryugu are a major breakthrough. Mr. Hiroshi Naraka, head of the research team at Kyushu University, Japan, said, "The presence of prebiotic molecules on the asteroid's surface, despite the harsh environment due to solar heating and ultraviolet radiation, as well as cosmic ray irradiation under high vacuum conditions, suggests that the uppermost surface particles on Ryugu have the ability to protect organic molecules." Previously, in September 2022, Japanese scientists also found water when analyzing 5.4 grams of samples from asteroid Ryugu. The discovery of water and amino acids in asteroid Ryugu is an extremely important discovery for science. It further strengthens the theory that the necessary materials for life were present very early in space. And according to a study also published in the scientific journal, the organic materials on Ryugu may even predate the formation of the solar system itself. They were formed in a primitive interstellar dust cloud that eventually coalesced to become Ryugu. In other words, many components for life could have been incorporated into the solar system from the beginning. Over time, they could have been transported to Earth through collisions of large asteroids with Earth. This opens up an extremely interesting opportunity. Imagine if liquid water and organic materials were present very early in space, even before the solar system formed and were transported to Earth by space rocks. That means they could also be distributed everywhere in the solar system and beyond throughout the universe. That is, if life formed on Earth, there's no reason why there couldn't be a second planet out there with life similar to Earth. Although we still haven't found a second planet beyond Earth with life, the results of this research could provide additional motivation for those working on exoplanet hunting, searching for extraterrestrial life. Although water and organic molecules have been found on Ryugu, the truth is that so far, Ryugu lacks many sugars and components of DNA and RNA, which have been detected in other asteroids. The research team suspects these compounds may be present on Ryugu, but due to the small sample mass, scientists haven't been able to find them yet. The Hayabusa 2 mission is only the second sample return mission where a spacecraft successfully brought samples from an asteroid back to Earth. In 2010, the first Hayabusa mission brought back dust from asteroid Itokawa. But due to a collection system failure, the obtained samples had very small mass, measured only in micrograms. Hayabusa 2 was more successful, bringing back to Earth more than 5 grams of rock from asteroid Ryugu. Analyses of Ryugu have only just begun, with many exciting things waiting for us ahead. NASA is also part of the collaboration with the Japanese Space Agency, so they received about 10% of the samples from Hayabusa 2 for testing. Additional studies are also underway in Europe. In September 2023, another sample return mission will also arrive on Earth. That is the OSIRIS-REx spacecraft collecting samples from asteroid Bennu. OSIRIS-REx is expected to return a larger sample mass from Bennu, and it will bring another important opportunity to search for traces of organic building blocks of life in a carbon-rich asteroid. Scientists are eager to compare samples between Ryugu and Bennu. Let's wait and see what surprise OSIRIS-REx will bring. So today, you and I have explored together the surprising discovery of life seeds in the Ryugu asteroid sample. Wishing you all an enjoyable video viewing. Hello and see you again in the next videos. Goodbye, everyone. Please subscribe to the Gian and I Go channel so you don't miss exciting